Guys, let's do this problem right here. The question is asking find the normal force, friction force, reaction force, and the phi, alpha, and f net. So let's see how we can find it. So first of all, let's see what is easy to find. The normal force. So let's begin with the normal force. So normal force is equal to, so if you see normal force, okay, before I do this question, I better make a triangle to make it clear, right? So this is my normal force in this direction, and we have a weight acting exactly vertical, so it's going to be down, and this is 20 Newton acting on it. Also, we have to know that the angle that's making with a horizontal, with a vertical is going to be theta, because you know this object, this is straight horizontal, and this is horizontal to the object. Since this is making 30 degree of this 30 degree here, it means it's also, if this is true, then it's also going to be equal to the vertical direction we are going to make with the surface and the straight vertical. So the angle between them are going to be equal to this theta. That's a general thing, because you're going to see in all the inclined thing, this is going to be a true statement. So therefore this is theta, and this is our n, and this is going to be w, and this is going to be f, right? So basically what is n is addition of these two forces, addition of the force created by weight and force created by the applied force. So how we can add both of them together? So if you see W, so W is making theta degree. So if I take W cos theta, it's going to be a component that's going to create n, right? So W cos theta. So first let's write W cos theta. Cos theta. Also F is going to be F sin theta is going to be one of the component of the n. So if you add both of them together, that's going to give you the normal force. So let's write this one. So F sine theta, and these two are going to give you the normal force. So is weight provided? Yeah, yes, weight is provided, and that F is also provided. Theta is 30 degree, therefore it's straightforward. We can calculate this n value by applying these things. So W cos theta is going to be 100 cos 30 plus F is given, that's 20 sine 30. Since if I calculate this value, this comes out to be 86.6 Newton, and the other ones comes out to be 8 uh, 10 Newton, 10 Newton, and if you add them together, this comes out to be 96.6 Newton. So this is my normal force, and let's see how we can calculate the friction force. So the equation of the friction force is normal force times the mu k. So mu k is provided here, so it's also straightforward. You can simply multiply both of them. So it's going to be 96 times 6 newtons times 0.2, that's the coefficient of friction. So if we multiply this one, we will get 19.32 newton. And R is so let's calculate R. So to calculate R, I have to draw that triangle right here. I draw it with a different color. Let's see. Okay, this is my N, and this is my R. Also, we have to know that the friction force is exactly perpendicular to the normal force, because if you see, this is acting exactly perpendicular to the surface, right? And friction force is along with the surface. Therefore, this is going to be making 90 degree with the normal force. So that's one thing we have to know, and this is going to be my N, and this is my reaction force, and we have a friction force. So to find the reaction force, I can directly use the Pythagorean theorem, because this is a 90-degree triangle, so we can directly apply Pythagorean theorem, right? So therefore R square is going to be equal to FR square plus N square. Therefore R is going to be equal to square root of Fr square n square. Fr friction force we already found out, which is equal to 90.3232. So I had to square it, plus n square is going to be 96.6 Newton. That's going to be 96.6 square, which is going to give me 98.5 Newton. So this is my reaction force. So we found normal force, we have found friction force, we have found reaction force, and we have to find phi. Let's see, this angle is phi. Now we have this value here, this value here. So if I apply tan theta, I can find the phi. So let's do this one. I use a different color. So tan phi is equal to opposite over adjacent for force of friction over normal force. So force of friction we know 19.32, normal force is equal to 96.6, and to find the phi you had to take the tan inverse of this value. So this is going to be tan inverse 19.32 over 96.6. If you calculate this value, this comes out to be 11.31 degree. Then there we have the phi. The next question is asking find the alpha. Alpha is the angle that's making with the reaction and the vertical. So let's see how we can calculate this one. So we know this is phi, and this is going to be the vertical is going to be my alpha. But we have to know one more thing. As I said already, the angle that's going to be making with the vertical and the vertical to surface is going to be equal to theta, as we found out here. Like I found out that between the weight and the normal force, that's going to be theta, because this vertical, we found this one theta, right? Also you can, if you find this one theta, also you can directly find the C shape is equal to theta, right? If this is theta, the C shape, if you form the C shape, that's going to be theta right here. Or you can use another technique that if you find the vertical, right, this vertical and the surface vertical, the angle between them is going to be theta, because here this horizontal and the surface horizontal is, the angle between them is 30 degree. So that's a general thing to know. And from this one I can calculate the alpha using this equation. So theta is going to be equal to phi plus alpha. Therefore alpha is going to be equal to theta minus phi. We know the theta already, it's 30 degree, and phi we found out here is 11.31, and if I substitute this one from this, I will get 18.7 degree. So this is my alpha value. We have found normal force, we have found friction force, we have found reaction force, we have found phi, we have found alpha, we have also, or we have to find force F of net force. So to find the net force, so we know there's a weight acting on it, 20 Newton acting on it, but this is like a straight vertical, straight horizontal. So we have to find this in terms of this object. So this object is actually inclined a little bit, so right, inclined along this one. So let's see how we can calculate this. So F of net is going to be equal to, so if you see this weight is going to be having two components, this component right here and this component right here. If you see, this component doesn't give you anything, because that's basically nothing actually. We have to find this component. This is along with this object, so this component gives me the value, and we know that this component's creating 90 degree with this surface, so therefore this is going to be theta. Since this is theta, to find this one I have to use sine theta. So W sine theta is going to be giving me the surface, that's the force that's going to create along with the object. So F net, one of my F net is going to be W sine theta, and I am taking this direction positive, so let's take this direction positive. And if I take this 20 Newton, the angle between them is 30 degree, as we know already here. The angle exactly horizontal to this surface, and the direct horizontal, the angle between them is 30 degree. Therefore I can say F cos theta is going to be the angle that's creating the force along this object. So see, since I'm taking this direction positive, this is going to be negative. Negative F cos 30. And also we have a friction force acting along with this one. So we can say that is also minus. We are taking this direction. So minus friction force. Force of friction. Now we have to find all the values. W is what? W is 100. 100 sine 30 minus F cos 30. F we already know 20. So 20 cos 30. And we know friction force here is minus 19.32. 19.32, and if you calculate all the values and sum it up, you will get 8 13.4 Newton. So that's going to be the final answer. So F net is equal to 13.4 Newton. So we found everything, right? That's how we do this question. I hope you guys like this video. See you next time.